Hello everyone, welcome to this markerless overlay training video. In this video I would like to show you a very simple example of a markerless overlay procedure. Here we have a frame. Let's say we want to put something inside a frame, ideally a nice painted Mona Lisa. This frame is a topography that I patterned with the NanoFraser. So you see, if I unselect this topography, you see a sort of a pattern with the optical camera image. So how do we approach a markerless overlay? First of all, we would like to scan the topography of the structure we want to put our design on. So we have to move towards the read arbitrary function of the NanoFraser, and we want to read this area. So optically we should be able to see if we have some flakes of 3D material, some markers that we put on our samples, or we should have an idea where our structure onto which we want to do an overlay are. So in this case I have a hint of where the this frame is, so I just scan this large area. You see, this is quite a large area, so it takes quite a long time to scan, but in this case we do not really have a small structure to scan. It's a very large and low resolution structure, so we can just increase the pixel size. So we have fewer pixels, will make our reading faster. See, we put a pixel size 50 by 50. In this case you see that now the reading area became red because we're exceeding the dimension of the piezo, and we can just increase the pixel time to reduce the scan region and make the reading area fit again. So we have reduced the reading time by around 2 minutes. We can even increase it more, let's say 70. Yeah, it's 1 minute and 40 seconds. We can press play and we start the reading. So we want to locate first of all our structure onto which we want to put our design. When we do overlay, it's important to keep in mind that when we allow the stage movement, then we also introduce errors associated to the coarse stage motion. So ideally we would like to scan the topography onto which we want to place our design, and then once we are there, we do not want to move with the coarse stage anymore, because otherwise we lose the maximum accuracy that we can achieve with the tool. So we move just within the piezo scanning range. So now let's have a look at our frame. This was a pattern in 10% PPA, spin coated on top of silicon at 4K RPM for 40 seconds, so around 180 nanometers of PPA. So we see that we have located our structure. We just wait for a few seconds until the reading is done. Okay, we have read again our structure. We can go to the write layout, and we can put our painting inside the frame. Actually, painting is here, this one, so we'll put it here. And we also uncheck this so that we don't move with the stage when we do this operation. One thing that's important to mention is that once we do the, let's say, official pattern of a topography, we would like to first do a test of our pattern somewhere else. Here I already did a test of this pattern, so if I check this box, you see that I did this test, so I made sure that I'm able to write decently, and I'm happy then after I place this design inside my frame, because hopefully I will get a nice pattern. So I use the Kalman feedback with the last converged state. Let's start now the patterning. So it's going to take 3 minutes and 40 seconds. Actually, I didn't reduce back to 25 the pixel time, so the patterning is going to take a little bit longer than usual, so be patient, or you can also skip this part when waiting for the pattern to be done. We see that we're patterning quite decently. Also, in this case, we have an adhesion length of our tip, which is not really good. It's acceptable, but it's already quite a used tip. So almost 100 nanometers adhesion length. It's quite a large value. So we should not be able to pattern in high resolution with such high adhesion length, but at the same time we see that even a grayscale lithography like this is patterned decently enough. It's actually quite a good result for such a large adhesion length. In this case, we don't really care about the patterning quality. We care about showing you the procedure of markerless overlay. For this specific design that we are patterning right now, we're talking about typical Mona Lisa. So it's a design that you can find in the geometry. And here, the non-freezer package. So it's a standard import of this file, no scaling, and depth between 15 and 40, pixel size of 20 nanometers in both X and Y. We see the details are not amazing, but for an almost 100 nanometers additional length, it's quite a good result. So this is also a good example that we can use to see practically that when we have an adhesion length that's quite large, we're still able to pattern, but probably it's not the best setup for an high resolution pattern. So our writing is done. Our Mona Lisa has been patterned. We see in the warm-up, that's actually here, but that's what the software tells us. So if we don't really trust the software about its position, we can always read again the whole area and see if we actually see the Nano Lisa inside. Also, in this case, we are using a pixel size of, we can make it even 4 times, 80 nanometers, right? I will just increase the pixel time so that we can make this fit. Of 80 nanometers for the reading. When we are doing the writing, we have a pixel size of 20 nanometers. So the details of the Mona Lisa in this reading will be not so nice as the ones that we just see here, because we have a larger pixel size. So of course, less pixels means less details, so our Mona Lisa is not going to be looking so nice. So we actually see our nice painted lithography in PPA of the Mona Lisa. It's quite nice, even with fewer pixels. It's still looking at us from every angle, like the real Mona Lisa. Anyway, jokes apart, I think this is quite a nice example to show you a simple markerless overlay. If you want to do a more complex overlay, more complex, I will say more integrated with other software like K-Layout on low dimensional structures or similar cases, you can also watch the other video that is also show you how to integrate this open in K-Layout function with the NanoFraser software, which is very useful and can also allow you to have a very high precision overlay with your low dimensional structures. So I hope this was helpful and can help you in having better results in your overlays with a NanoFraser for your research.